Hi, welcome to another lesson in the series of engineering chemistry. So, for this lecture, we're going to look at the organic compounds, the nomenclature, the alkanes, the functional group, alkenes, alkyne, and the aromatic compounds. And this is lecture 7. So, what is an organic compound? So, an organic compound is made from carbon atoms and they have one or more carbon atoms in their structure, and they have so many hydrogens in their structure. Sometimes they also contain oxygen, sulfur, nitrogen, phosphorus, and halogen also in their structure. So properties of organic compounds, they they contain carbon, like we've said, and they have covalent bonds. They have low melting points, low boiling points. They are flammable, and they are not soluble in water. So when you compare organic compounds and inorganic compounds together, as you can see that mostly organic compound will contain carbon and nitrogen. They can also contain others. And then mostly inorganic are metals, either metals and non-metals in their structure. Organic compounds are mostly covalent, or inorganic are ionic, and sometimes also they are covalent. In terms of polarity, organic compounds are nonpolar, and unless a very electronegative atom is present. And inorganic compounds are ionic or polar covalent, and a few are also nonpolar elements. So in terms of melting point, like I have said, they are low. Their boiling point is also low, but for inorganic, they have high um, um, melting point and high boiling point. Organic compounds are highly flammable. Inorganic are low. So in terms of solubility in water, they are not soluble. Organic compounds are not soluble unless you have a polar group uh, present. But for inorganic, they are mostly soluble unless you have a non-polar group present. So hydrocarbons. What are hydrocarbons? Hydrocarbons are molecules that are made of carbon and hydrogen only. So as the name sounds, hydrocarbon. So they are just hydrogen and carbon in their structure. So we have four types that we want to discuss today. So we have alkanes. These are the ones that they don't have double or triple bonds. They're just single bond. Example is propane. Another example is of hydrocarbon is the alkenes. Those are the ones with double bonds. You can see the example is propane. The third one is alkyne. Alkyne are the triple bonds. So they are the one that have triple bonds, for example, propane. Then we have the aromatic compound. Aromatic compound are basically the benzene rings kind of compound. So example is the ethyl benzene. So example of, we're starting from alkanes. So example of alkanes, you can see we have methane, we have ethane, we have propane, we have butane. Now you can see them with their structural formula. So they have organic, they have carbons, and they have many hydrogens surrounding them. And then please note that when you have a carbon in organic chemistry or even in any type of chemistry, they want to be stable by gaining 4 electrons to themselves. That's why mostly in inorganic compound you see that carbon is being surrounded by 4 bonds. So mostly these bonds are coming from the combination with hydrogen. So we have this methane, which is CH4, being surrounded by 4 hydrogen because it wants to be stable. So it needs 4 hydrogen to be stable. So when it comes to naming them, how do we name them? We name them in terms of the number of carbon that is present in their structure. So for example, when you have 1 carbon, it's called methane. So you start with the prefix methane. So when you have 2 carbons, it's going to be ethane. When you have 3, propane. When you have 4, butane. 5, pentane. 6, hexane, and so on and so forth. So you name them with that. So all you need to end the name by A, N, E. So if it is 1 carbon, it's going to be methane. 2 carbon is going to be ethane. 3 carbon is going to be propane, and so on and so forth. As you can see, CH4, C2H6, C3H8, and so on and so forth. And you can see their condensed structural formula being written out there. So for alkane, there is a general formula for them, which is CnH2n plus 2. So if your N is 1, so that means the carbon is going to be 1, and it's going to be methane. And then the number of hydrogen will be 2 times 1, which is 2 plus 2, which is going to be 4. So that's why it is CH4. So when N is 2, you're going to be C2. That means you're going to have 2 carbons. Then your hydrogen is going to be 2 times 2, which is 4, plus 2, making 6. And that's why we have 6 hydrogen. So it is C2H6. Then for propane, propane suggests that it's going to be 3 carbon. So we have 1, 2, 3. So if your N is 3, you put 3 there, that will be 3. And then this will be 2 times 3, and that is 6 plus 2, 8. So you're going to have 8 hydrogen, 1, 5, and 8. So how do we name alkanes? First, we follow some rules. The first one says find the longest continuous chain of carbon atoms and use the name of this chain as the base of the name. So the first thing is to look for the longest chain. So when you get the longest chain, then you got to know whether it's going to be propane or octane or hexane. The second rule says that the longest chain, you begin with the end of the chain nearest to a substitute. So if you have a substitute on the chain, then you have to start counting from the carbon to the nearest substitute. The third rule says that you name the group attached to the longest chain. You give the location of the group, if it is an alkyl group or any branch substituent. So by giving the name of the main chain atom to which it is attached. So when you have a substitute on the longest chain, you give the name of the carbon that the substitute is attached to. Then you also give us the name of the substitute. So write the balanced substitute in alphabetical order, regardless of the position of the chain. So it doesn't matter where you see the substitute on the chain, you have to arrange the name in alphabetical order. The last one says that you should write the name in a single word. So when you have numbers, you can separate the numbers by just comma. When you have a number and letters, then you can just say the number, then dash, then the letter. Like, for example, 3-methyl. So let's take this as an example. First, they were asked to count the longest chain so that we know the parent name. The longest chain can be 1, 2, 3, 4, 5. Is that the longest chain? We don't know. Let's count again. 1, 2, 3, 4, 5, 6. Oh, now we have 6. So 6 is going to be the longest chain. So, but the rule says that you must count with the nearest substitute. There is a substitute here. So that's why we're counting from here. 1, 2, 3, 4, 5, 6. So if you count from there, that means on carbon 3, there's a methyl substitute there. And that's why the name is 3-methyl hexane. Remember, when it is 6 carbon as the longest chain, it's going to be hexane. So there are a common alkyl group that you can find as a substitute. When it is CH3, it's called methyl. When it is C like this, that's C2H5, then it's going to be ethyl. When it is C3, 3 is going to be propyl, and so on and so forth. So when you have them like this, then you name them in such. When we have 4 carbons, 1, 2, 3, 4, then it's going to be butyl group. So these are alkyl group. Alkyl group are the kind of alkane, but they've lost and hydrogen. So when they've lost an hydrogen, then they become a butyl methyl. Instead of this to be CH4, it is CH3. That's why it is methyl instead of methane. Instead of this to be C2H6, but because it has lost an hydrogen, it is C2H5. So it's not going to be ethane, it's going to be an ethyl group. So that's how we form alkyl groups. So let's look at the example again. The rule 2 says that we have to count from the nearest to the substitute. And this is a substitute, and that's why we're counting from here. If we count from here, it's going to be 1, 2, 3, 4. But if we count it from here, it's going to be 1, 2, 3. So this is the nearest. That's why we're counting from here, and that's why the name is 3-methyl-hexane and not 4. If you count from here, it's going to be 4. 1, 2, 3, 4. It's going to be 4-methyl. Okay, let's look at this example, alkyl substituent. So let's say you have more than one substituent on it. First, the rule says we should count the longest. And what is the longest? Chain. So this is 1, 2, 3, 4, 5, 6. Okay, we can also count like this. 1, 2, 3, 4, 5, 6. It's the same thing. That means the longest, whichever way we count it, the longest chain is going to be 6 carbons. And then there is a substituent here, there's a substituent here, and the rule says we have to count from the closest. That means that we're going to start counting from here, because on carbon 2 there's a substituent. If we start counting from here, it's going to be carbon 3. 1, 2, 3. So we're going to start counting from here. So that's why we have 1, 2, 3, 4. So on carbon 4, there's an ethyl group there, C2H5. C2H5, ethyl. This is CH3, methyl. So that's why the name is going to be, and remember, another rule says that when you are naming, you must name in alphabetical order. And that's why ethyl is going to come first. And that's why it is 4 ethyl, 2 methyl hexane. Because on carbon 4, there's an ethyl group there. On carbon 2, there's a methyl there. But when you are naming, you name in alphabetical order. So we're going to name 4 ethyl first. On carbon 4, that's what that 4 is telling us. So on carbon 4, there's an ethyl group. On carbon 2, there's a methyl group. Then the longest chain is hexane. So let's say we have other substituents. Now, let's check this example first. See, this compound is the same thing as this compound. That's no difference. So if you check them very well, that's no difference. So let's count the longest chain. It's going to be 1, 2, 3, 4, 5. So the longest chain is 5, and that's going to be pentane. So, and what happened on carbon 2? On carbon 2, there's a methyl group there. So that methyl group is, so if you want to name, so you're going to say 2-methyl pentane, because on carbon 2 there's a methyl there. That's why we have 2-methyl pentane. Let's say we have other substituents like chloro, bromo, iodine. The first thing is to do is to count the longest chain. Let's count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So whichever way we count it, the longest carbon chain is 6. So it's going to be hexane. The structure is going to be hexane. But how do we count? We need to count from the nearest substitute according to the rule. So we cannot count from the left. We're going to count from the right. So we have 1, 2, 3. So on carbon 3, what happened? We have a chloro there, and we have an ethyl group there. So if we want to name them, which one will come first? The chloro will come first in alphabetical order. And that's why we have 3 chloro, 3 ethyl, hexane. 3 chloro, 3 ethyl, hexane. More example. First thing, count the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. No. So that means the longest chain is 8, octane. So the structure is going to be octane. The second rule says that we must count from the nearest substitute. So if we count from here, 1, 2, 3, on carbon 3, there's a methane there. On carbon 4, 5, on carbon 5, there is another branch, 10 gram. That is C2H5, and that is ethyl. C2H5, that's ethyl. So that means if we want to give the name, remember that we have to give the name in alphabetical order. So ethyl will come first. Ethyl is on carbon 5. That's why we have 5 ethyl, 3 methyl, octane. Because we can 1, 2, 3, there's a methyl group there. 4, 5, there's an ethyl group there. Then you can finish the rest. So 5 methyl, 5 ethyl, 3 methyl, octane. All right, so another example, you can see this is what we call the bond line structure. So each point is representing a carbon. Each point is representing a carbon. So if you count the longest chain, we have 1, 2, 3, 4, 5, 6, 7. So the longest chain is 7. And 7 is going to be what? Heptane. And what happened on carbon 3? There's a methyl group there. That's why we're going to have 3 methyl heptane. So more examples. So let's see. First, we need to count the longest chain. So if we open this bracket, we're going to have this. So if we count the longest chain, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is 8 carbon, octane. And what happened on carbon 2? On carbon 2, there's a methyl group there. 2, 3, 4, 5, 6. What happened on carbon 6? There's also a methyl group there. So now we're having 2 methyl. That's why we're having 2, 6 dimethyl octane. 2, 6 dimethyl octane, because there are 2 methyl group there, and that's why they are di. We put that di there, methyl. So more examples that we can see, and if we follow the rules, we'll see how we derive these names. So for example, if we count from here, 1, 2, 3, 4, 5, 6. So the longest chain is 6, that's hexane. But on carbon 2, there's a methyl group. On carbon 4, there's a methyl group, and that's why we have 2, 4 dimethyl. On carbon 3, there's an ethyl group, C2H5 ethyl, and that's why we have 3 ethyl, 2, 4 dimethyl hexane. So and so on. If you also check this, first thing is to count the longest chain, 1, 2, 3, 4, 5, 6, 7. So 7 is the longest chain, and that is heptane. So on carbon 2, there is a methyl group. On carbon 4, there is a methyl group. On carbon 5, there is also another methyl group. And that's why we have 2, 4, 5 trimethyl heptane. So if you look at this, then you'll be able to decipher the names and then correlate them with the structure that we've given. So this is our learning check. Try and do this on your own, and let's see what you're gonna get. So also you draw the condensed structural formula where you're going to write them in form of CH, CH3, CH2. Those are the condensed formula. So let's try and draw this out, and let's see what we have. Okay, so Alkene isomers. So they have the same molecular formula but different in structure. So the way they structure them are different. For example, this is 1, 2, 3, 4. When you have 4 carbon, they are what? They are butane. Okay, but that doesn't mean that this is also a butane, because there are 4 carbons there. 1, 2, 3, 4. So it doesn't make it a butane. Instead, it is called isobutane, even though there are 4 carbons also there, but it doesn't make it a butane. This is, if you name this properly, it's going to be 1, 2, So on carbon 2, there's a methyl group there. There's a CH3 there. So that's why it is 2-methyl propane. So that means 2-methyl propane can also be called an isobutane. So that's what we call isomers, when you can have more than two structure, more than one structure to a compound. For example, butane. Another example is pentane. Pentane has 5 carbons, 1, 2, 3, 4, 5. But if you look at this compound also, 1, 2, 3, 4, 5, it also has 5 carbons, but it is not pentane. It is 2-methyl butane. Let's count 1, 2. So on carbon 2, there's a methyl there. So that's why it is 2-methyl. Then the longest chain is 4. Butane. So it's 2-methyl butane. Also, we can have another isomer for pentane. If you count the number of carbon, 1, 2, 3, 4, 5, there are 5 carbons, but that doesn't make it pentane, because if you check the longest chain, 1, 2, so on carbon 2, we have a methyl group on top, we have a methyl group below also. That's why we have 2,2-dimethyl propane. 1, 2, 3, 2,2-dimethyl propane. So even though they are having the same number of carbon, but they are not the same thing, that's what we call the isomers. So we call them isomers. Okay, so we have cycloalkanes with general formula CnH2n. So these are alkanes that are in form of cycle, and they start from carbon 3. So when you have 3 carbon in cycle like this, it's called cyclopropane, because it's 3 carbon. When you have 4 carbons, it's going to be cyclobutane, because there are 4 carbons. Then where we have 5, then it's going to be cyclopentane, cyclohexane, cycloheptane, and so on and so forth. So how do we name them? So you can just name them directly. Like we have, this is methyl group attaching to a cyclohexane. So you can just name them directly as methyl cyclohexane. This is an ethyl group, C2H5, attaching to how many carbon? 1, 2, 3, 4, 5. So that's cyclopentane. So that's going to be ethyl cyclopentane. So you write the name as 1, cyclopentane. More examples. So if you now have more than one substituent on the ring, on the cyclo, then you can now give us the position. So let's say we start counting from here. And then when you are counting, make sure you count from the side that will give you the lowest possible number. And that is 1, 2, 3. If you count from here, it's going to be 1, 2, 3, 4, 5. No, it's too far. So you count from here, 1, 2, 3. So on position 1, we have a methyl. On position 3, we also have another methyl. And that's why it's 1,3-dimethyl cyclohexane. The total carbon in the cycle is 6, and that's why it's hexane. So it's 1,3-dimethyl cyclohexane. If you look at this also, let's give this position 1. So we count 1, 2, 3. So on carbon 1, we are having 1, 2. 2 methyl there. And then on carbon 3, we have 1 ethyl. And that's why when you name them alphabetically, it's going to be 3 ethyl, 1, 1 dimethyl cyclohexane. 1, 1 because there are 1 there, cyclohexane. So more, you can see that, so for example, if we call this 1, 2, 3, so we can say 1 bromo, 3 methyl, cyclo, how many? 1, 2, 3, 4, 5, cyclopentane, and so on and so forth. Look at this also. So let's call this also 1, and let's call this 2. So that means on carbon 1, we're having 2 methyl there. That's why we have 1, 1 dimethyl. Then on carbon 2, we have an ethyl there. That's why we have 2 ethyl, 1, 1 dimethyl cyclohexane. So these are learning checks for you that you can go through, and just follow the step that we've followed in previous slides, and you should be able to get them. So these are the properties of alkanes, and please try to note them that from carbon 1 to 4, they are all gases at room temperature. From 5 to 15, they are liquids at room temperature, and 16 and above, they are wax with low melting point. They are odorless, colorless, and tasteless. They are non-polar and are insoluble in water. They are less dense than water. They are very flammable, and increase in melting point and boiling point with an increase in molecular weight. So alkane undergo some reactions, and one of them is combustion reaction, that's oxidation. Remember, we did it in our previous lecture that when an organic compound is being burnt, it goes from it transforms to CO2 and water, then it liberates energy, and one of the energy we use it in driving our cars. Then we have halogenation. Halogenation is when you add an halogen to an alkane. So, for example, you can see bromine is being added to this compound, and then it gives you can see that bromine is now being attached. So the compound they're called halogenated alkanes. Then it gives you your hydrogen halide on the other side. So we have functional groups. So functional groups are what you see in an organic compound that when you see them, then you know the kind of reactions or the kind of groups that they belong to. So for example, when you have a compound, organic compound, with just single bond and no other functional group, they're called alkane. But by the time you have one with double bond, they're called alkene. Triple bond, they are called alkyne. When you have OH, they are called alcohol. Then you have har, ho, har, then you are called ether. So and so on and so forth. Then we have carboxylic acid. So please try to check this chart and get used to these functional groups. This is an example. As you can see, the benzene ring here is telling us that it has an arene functional group. So the NH2, that is, it's telling us that there's an amine group there. Then we have the COOH, this one in red, is telling us that there's a carboxylic acid. So when you have O is CH3, it's telling us that there's an ether group there. Then you have the double bond, it's telling us that there's an alkene group there. Then let's move to unsaturated hydrocarbons. So we have some hydrocarbons called unsaturated. Why? Because their surroundings, the carbon, they have lost hydrogen or hydrogens. So they are not saturated with hydrogen around the carbon. So example is the alkene groups. The alkene groups are the one with double bond. As you can see, so we are seeing the double bond in between the two carbon. So this kind of compound are called alkene. Then we have alkyne groups. These are the one with triple bonds. For example, you can see ethine here, triple bonds in between the carbon. So how do we name alkenes? We also name them just like the way we named alkanes. All you need to do is to change the ANE to ENE, so that what you have is going to be, so instead of ethane, it's going to be ethene. Instead of propane, it's going to be propane. Instead of cyclohexane, it's going to be cyclohexene. So this is a popular alkene that I think you need to know, is C2H4. And it's popular because they use it to accelerate the ripening of fruits. So you have fruits and you want it to ripen so quickly, and you introduce ethane or ethylene, commonly called, to it. So how do we name alkyne? Alkyne are the one with triple bonds. So it's the same thing, just change the ANE of the alkane to and Y and E. Then you get your alkyne. So instead of ethane, it's going to be ethyne. Instead of propane, it's going to be propyne. So how do we name them? We said we've gone through this before. Name the longest carbon chain with double or triple bond. Then number the carbon chain starting from the end nearer to draw double or triple bond. That's very important. So when you want to name alkene or alkyne, you have to start from the nearest double or the triple bond of the compound that you want to name. Then the third step says you give the location and the name of the substituents. So let's see these examples. This is, you count the longest chain first. 1, 2, 3, 4. That's going to be but something. Okay. So what is the something? That's a double bond. So it's going to be butene. Butene. It's not going to be butane. It's going to be butene. Let's count this also. 1, 2, 3, 4. But there's a triple bond. So it's also going to be butyne. So that's why we have butene and butyne. So the next thing is to check the position of the double bond. The position of the double bond. So if we can't, the rule says that we should count from the nearest to the double bond. So we count from here. 1, 2, 3, 4. 1. That means on position 1. After 1, we have the double bond. If you check this, 1, 2. After 2, we check 1, 2, 3, 4. So on position 1, we have the double bond. If you check this, 1, 2. On position 2, we have a triple bond. And that's why when you want to give the name, the final name, it's going to be 1-butene, because on position 1, there's a double bond. On position 2, there's a triple bond. So it's going to be 2-butyne. Okay, I've mentioned this earlier, that you have your alkane. So instead of ethane, it's going to be ethene. Then it's going to be ethyne. Instead of propane, it's going to be propene. Then it's going to be propyne. More names, let's check. First is to count the longest chain. 1, 2, 3, 4, 5. Then we must count from the nearest double or triple bond. So we are correct. We count from here. 1, 2. So it's going to be pentene. But what happened on 1, 2, 3, 4? On position 4, on carbon 4, as you can see, there's a methyl group there. So we need to name the methyl group. So it's going to be 4-methyl 2-pentene, because on carbon 2, there's the double bond. That's why the 2 comes in. 4-methyl 2-pentene. And that's the name of that compound. Another one. Let's see. Let's count. 1, 2, 3, 4. So the longest chain is but. So it's going to be butyne because of the triple bond. Okay, so how do we count? Did we count correctly? We started from here. Yes, it's correct because triple bond is nearer to this side. So we say 1, 2, 3. So what happened on position 3? There's a methyl group there. And that's why it is 3-methyl. 1-butyne, because of the triple bond is immediately after carbon 1. So it's 1-butyne. 3-methyl, 1-butyne. Lightning check. Okay, it's already done. So we can see that 1, 2, 3, 4. I don't know, carbon 1, there is a double bond. That's why it's 1-butene. So for this 1, 2, 3, now let's count from here. 1, 2. There's a double bond there, and there's a substituent here. So on carbon 2, there's methyl. That's why it's 2-methyl. And on carbon 2 also, there's a double bond. That's why it's 2-butene. So 2-methyl, 2-butene. If you also check this out, if you count from here, which is the nearer, 1, 2, 3, 4, 5. So it's going to be pent. Pent what? Pent of the triple bond, pentyne. And then on 1, 2, 3, 4, on position 4, there's a methyl group there. That's why we have 2-methyl. Then on carbon 2, there's triple bond. That's why we have 2 pentyne, 4 methyl, 2 pentyne. All right, more learning check for you guys. So you have to draw the condensed structure formula for each. So 2 hexane, draw for 2 methyl, 3 hexane. Then also name this. If you use the previous slide that we have, you should be able to name this. Thank you. All right, so there are some properties of alkenes that we need to know, the cis and the trans isomers. They are possible because the double bond is rigid, cannot rotate. So remember that alkenes, they contain double bond, and therefore when you are writing their structure, you have to be specific of the position of some of the substituents that are on them, and that's why we come about cis and trans isomers. So it is cis isomers when you do your finger, you do the double bond like this, and then your thumbs is up, the 2 thumbs are up, and that's cis. So when it is opposite, and that is trans isomer. So for example, see the bromine, the 2 bromine are up, so it's going to be cis. What is the longest chain? 1, 2. So it's going to be on carbon 1, there's a bromine, on carbon 2, there's a bromine. That's why we're 1, 2. Dibromo, ethane, but we need to put cis, because if you say it's 1, 2 without cis, this bromine can be bottom here, and that's going to be a different thing entirely. For example, look at this. This is also 1, 2 dibromo ethane, but they are not equal. These compounds are not similar because of the position of the bromine. That's why we have to put cis. This one is cis because the 2 bromine, these 2 substances are on top, and then we have trans, which are the 2 substances like adjacent to each other. So more examples. Okay, this is also similar. Cis 1, 2 dibromo ethane. Then we have yes, look at this. The longest chain is 1, 2, 3, 4. But if you look at the position of the methyl, they are in a trans position to each other, and that's why we put trans 2-butene. Trans 2-butene, because they're in trans in terms of position to each other. Look at this final example. Is this trans or cis? It's none, because if you check this, you discover that these 2 chloro, they are on the same side, and they are the same thing. See, as you can see that you are having the chloro on the same side. So because they are identical, then you can't say it is cis or trans. If you check other examples, you can see that they are different. They are different, but these are identical. So once they're identical, then there's nothing like cis or trans isomer. So you just give them the name directly. If you can't, the longest chain 1, 2, 3, it's going to be on carbon 1, we have 1 chloro, 1 chloro. That's why we have 1, 1 dichloropropene, because the longest chain is 3 propene. So the unsaturated hydrocarbons, like the ones with double or triple bond, they undergo what we call addition reaction, and that's when you add something to them. For example, you have A, B to Alkene, that give you A, then B, so it's an addition reaction. So we have types of addition reaction. For example, we have hydrogenation when you add hydrogen. We have halogenation when you have halogens. We have hydrohalogenation when you add an alkyl, when you want to produce an alkyl halide. Then we have hydration when you add water to it. So for hydrogenation, that's when you add hydrogen in the presence of catalyst. So you can see the double bond is being broken, and then the 2 hydrogens are attached to the carbon carrying the double bond. So you can see an example in the presence of catalyst. This will the reaction will proceed, and then you have your compound, then the double bond will disappear, and then the hydrogen will be attached to the carbons carrying the double bond. Then we have halogenation. That is when you add halogens to it. For example, you see bromo is being added, then the double bond disappears because the bromine is now being attached to the carbon, and then you have that. And you can see even for this example, triple bond, we're having 4 chlorine, 2 times 2, 4. So we're having 4 chlorine now attacking the triple bond, and then this triple bond disappears, then we have this compound. That's halogenation. For hydrohalogenation, that is when you are adding compound that contains an hydrogen and an halogen to unsaturated hydrocarbon, then you're gonna have something like this: the hydrogen attached, then the chlorine also attached to the double bond carrying the carbon carrying the double bond. What is the name of this compound? Okay. You can see that when you add HBr to it also, the double bond is broken, and then you have hydrogen and then the bromine attached. That's hydrohalogenation. Then we have hydration. Hydration is when you add water to it in the presence of catalyst, mostly an acid catalyst. So when you add to it, then you have the hydrogen, then the OH. Then when this kind of reaction occurs, then you're going to generate what we call an alcohol. This is a functional group, an alcohol. So look at this example also. You add water in the presence of hydrogen, an acid, then you have this, you have the OH and you have the H, producing an alcohol. So check this reaction, then you should be able to know the type of reaction that is being taking place under this learning check. Then the last aspect that we want to look at is the aromatic compounds. So benzene is a parent of the family of aromatic compounds. So when we are talking about aromatic compound generally, we want to discuss like the chemistry of benzene. So don't confuse benzene and cycloalkane together. For example, cyclohexane. Cyclohexane does not have double bond, and even if it does and double bond is now up to 3 in the ring, then it's still an unsaturated, maybe alkene. So you can see that the benzene 6 carbons, and then you have the double bond. It doesn't matter the position, so far you are leaving a space in between them because of the resonance. Sometimes we represent benzene as this, just the 6 ring, then you put the circle inside. So this is the structure. So carbon has 6 carbon, benzene has 6 carbon atoms, and it also has 6 hydrogen, as you can see from here. 1, 2, 3, 4, 5, 6. So 6. So carbon is C6H6. C6H6. So that's benzene itself. So how do we name them? Well, you see, there's a methyl there. You can just say methyl benzene, and then we have a chlorobenzene. Sometimes you need to give the position, like you say 1 methyl benzene or 1 chloro benzene, but this is also fine. Then we have some common names for some aromatic compounds, because these aromatic compounds have been in existence for ages. So we have common names for them before the IUPAC and come into being. So for example, this is toluene. So when you have a benzene ring with a methyl group attached to it, just call them toluene. Then we have aniline. When you have a benzene ring with NH2, then you can just call them aniline. Then we have phenol. That's when you have OH attached to a benzene ring, then you can call them phenol. And these are also their names. That's methyl benzene, benzene amine, and then hydroxybenzene. Okay, so this is more examples. This is bromine, so we can just say bromobenzene. This is nitrobenzene, and then 1, 2, 3. That's gonna be propyl, 1-propyl benzene. If you want to put the position there, 1-propyl benzene. So again, when you now have like two groups attached to the benzene ring, then you want to give number, and when you're giving number, you have to give the number that will give you the lowest kind of number. For example, also apart from the number, you can also use, so when you have 1, 2 is ortho, when you have 1, 3 it is meta, and when you have 1, 4 it's called para. We'll get to that later. So let's see. This is gonna be, so if you want to attach number, you can just say 1, 2, 3. Don't count from here, it's far. You count from this side, 1, 2, 3. But remember that this structure itself, without chlorine, this structure is called toluene. It's called toluene. So you can just say this is gonna be 3-chlorotoluene, because this compound is toluene itself. And you can see it is 1, 2, 3. So because it's 1, 3, you can say M-chlorotoluene. That M stands for meta. Then you see, this is, if you attach number 1, 2, 3, 4, this is going to be 1,4-dichlorobenzene, or you call P-dichlorobenzene. P is para. If you check the previous slide, we said when this is 1, 4, it is para. And then this is going to be 1, 2. But remember that an OH attaching to a benzene ring is called phenol. So that's why you can just count 1, 2 and say 2-chlorophenol. Okay, it's correct. Or if you say O-chlorophenol, this is O standing for ortho. Ortho is 1, 2. When you have a 1, 2 position, it's called O-chlorophenol. Orthochlorophenol. All right. So now you can also have multiples substituent, more than 2, 3, 4, 5, and so on and so forth. Then that means that you're going to attach number again. So for example, if you say this is 1, 2, 3, 4. Okay. We are counting from this side because it's nearer to the second one is nearer to the first substituent. If you count from here, it's far. 1, 2, 3, 4, then 5, 6. 6, then it's going to give you 6. But if you count from here, the highest that you're going to have is 4. So that's why we have 1, 2, 3, 4. That means you're going to have 4-chloro, 1, 2, dimethylbenzene. The same thing, if you count from here, 1, 2, 3. That's good. So that means you're going to have 1 bromo, then 3 ethyl, that's C2H5, then 2 nitrobenzene. Remember that when you are giving name, you have to give name in alphabetical order, and that's why it's like that. And sometimes you can use the apparent name, that's toluene, because ordinarily this, if you neglect this NO2, then this structure is going to be toluene. So that means if you count 1, 2, 3, 4, 5, 6. So on carbon 2, carbon 4, and carbon 6, we're having nitro. That's why we have 2, 4, 6 trinitro, because there are 3 nitro. Trinitro, then you have toluene. If you look at this also, OH attaching to benzene ring is going to be phenol. So if you start counting from here, 1, 2, 3, 4, 5. So you're going to have 5 bromo, then 2-chlorophenol. The same thing, this is carboxylic acid group. So this is going to be a carboxylic acid attaching to a benzene ring, then it's going to be benzoic acid. So if you count 1, 2, then it's going to give you can say 2-bromo, or you can say ortho-bromo, because it's 1, 2 position. Benzoic acid. So these are common names that you can go through. We have benzene, toluene, phenol, aniline, xylene, so on and so forth. So Learning check. What is going to be this? This is 1-chlorobenzene because you want us to know the position so it's correct. And this is going to be 1, 2, 3. So it's going to be 1,3-dimethyl benzene. But do you know that if you also say this is M-xylene, you are correct? Because if you check the previous slide, another name for compound like this is called xylene. So you are also correct. Learning check. So draw the condensed structural formula for each of the following: 1,3-dichlorobenzene and orthochlorotoluene. More learning check. Identify the functional group. This should be easy. What is the functional group that has double bond? And when you have double bond, they are called what? And then this is in a cycloform. And then we have triple bond there. Then this is going to be what? This is not cyclo. Okay, should be able to get what this is. So what are the properties of aromatic compounds? So they have a stable aromatic bonding system. They are resistant to many reactions, but they undergo what we call substitution reaction. So what are the substitution reactions that they undergo? It's when you take the hydrogen atom for a benzene ring, then you replace it with another atom or group of atoms. That's what we call the substitution reaction for benzene. So they undergo halogenation, nitration, and sulfonation. So this is halogenation. So in the presence of an halogen, when you react them with an halogen and in the presence of catalyst, then the hydrogen here is going to be replaced by chlorine. Then you have HCl, and that's halogenation. So for nitration, we use nitric acid in the presence of an acid like H2SO4. So at the end, the hydrogen at this position is being replaced by NO2. Then you have water. Then also sulfonation. So when you react it with SO3 in the presence of acid also, most especially H2SO4, then you have SO3H replacing the hydrogen on this position. So these are the learning checks. Please try to name this following by using the steps and the principles and the rules that we've discussed earlier. And that's the end of this lecture. Thank you.